All right, so Bob, I see you brought some photos here of thermal spray applications that maybe just be found in everyday life that we might not even know happened. So can we walk through some of these photos and learn more about them?
Sure. Yeah. Again, this is one of the things I love about my job is getting in to see how different things are manufactured. What we have in front of us here is a valve from an engine. Well, it's not just any ordinary valve. That's a racing engine valve, and it's made of titanium. So it's very lightweight. In racing engines, they want to be able to accelerate the parts as quickly as they can, so they want them as light as possible. Now, that's great that they use titanium because it's lightweight, but the problem with titanium is it galls. So titanium against aluminum, titanium against steel, it'll just gum up and gall and just stop working, and that's not good. So in this case, what they do is they spray that stem with a moly alloy. It's a nickel cobalt moly alloy that gives, moly is a metal that has what they call lubricity. So moly can rub against aluminum, it can rub against steel, it can rub against titanium, and it won't go. It'll keep sliding. If you have a little bit of a thin oil film on there, it'll go very long. So they actually forge this out of titanium stock. They machine it down and they spray the moly alloy on, and they finish grind it to the size that they want. So it's an everyday racing engine application. But this is one we actually did a little video on this one. This is a olive oil barrel. And what it is this was formed out of a galvanized sheet steel, which was, I think that's a 36-inch high, maybe 40-inch high barrel. So they start off with a strip of galvanized steel. They put the ribs in it, and they form it into a circle. And up at the top there, you'll see there's a lighter colored stripe. That's where there was a weld that was done on the barrel to join it together, and it was sprayed on the inside to galvanize it to give it protection for corrosion. So again, this is used in olive oil manufacturing. Now once they put the bottom on, they'll also put a food grade sealant on there, which is kind of like a paint, so they can make sure they adhere to all the federal Federal Drug Administration rules on how to have contact with food grade materials with metals.
That's fascinating. And we did agree thermal spray is making your olive oil taste better. We decided.
Yes, it is. And I would invite you to find this one where we actually show how this barrel is sprayed. It's a pretty cool video. This is what's called a compressor rod. It's a little hard to imagine this, but compressors have pistons on them. And in industrial applications, compressors can have very large rods. So in this particular case, on the right side there, you see that on a large round thing, that's the actual piston to the compressor. And in this case, it's hard to visualize what size that is, but that's probably 14 inches in diameter. And it's connected to that long rod. And that long rod is being sprayed with a tungsten carbide. Because in these large compressors, there's a lot of friction and a lot of wear because of the high pressures these compressors see. So this compressor might be for natural gas compression. It might be for compressed air, or there's other gases that they want to compress. And these are long rods that have to be coated and repaired. This is a shaft that was damaged. You can see the threads on there on one end. And we did a video on this complete process and how to do this. But in the upper part of the picture there, you can see what's a pretty rough surface on the shaft. And there's two smaller diameters. That's where the bearing and the bearing seal go on this particular shaft. And they were damaged as badly as the upper part there. So they machined it undersized. They thermal sprayed it with a stainless steel, and then they machined it back to the original dimensions. So they salvaged this shaft. And then you can see the threaded end on there. That's where a nut is that holds the seal and the bearing in place. This gentleman is actually spraying a girder for a bridge, and he's spraying zinc. And if you look at it closely, you see his head's just about to hit the top of the flange of the girder, and down about a little bit below his knees is the bottom of the flange. And there's that web there that has little holes in it. That's what's called a stiffener. So if you're driving along and you look up, and if you're going under an underpass and you look up, you'll see these big I-beams and girders. Some of those are sprayed with zinc for corrosion protection. So they'll spray them with zinc, and then they spray them with a paint, usually put a coating on top of that.
So what does that process look like? I mean, obviously, that's a massive piece of metal. Is that moved, or is that just placed and then the thermal spray operator moves about that?
Well, it can happen both ways. Some manufacturers have these girders or I-beams on carts, and they'll move them through a relatively small room and do all the thermal spray in one small room. And other manufacturers have very long rooms with large fans that pull the dust through to the other end, and they have the beam stationary or the girder stationary. So it really depends on what the overall situation is at the manufacturing facility. Some companies don't have the room to be able to pull a girder through because you have to have length on both sides. So if you have a 100-foot long girder, you need a 250-foot long room to pull that girder through a room. So if you have a smaller building, you have to do the fixed building that, or the fixed room that's only 100-foot long, only take up 100 foot of the floor space. This is an anti-skid application. And I have the pen on there because it's hard to visualize this. But if you're walking downtown and you walk over the steel plates that are access holes for electrical components and plumbing components in downtown areas, you'll see it sometimes a rough texture. Sometimes they use diamond plate, but diamond plate's still slippery with a little bit of ice. This is actually a very rough thermal spray coating that goes on top of steel or stainless steel to give, I always use the word gription. Well, there's one time we were talking to a elderly gentleman, and he said, "Yeah, I put new tires on my car and I got great gription now." So I use the term gription. So it gives a lot of friction so that your foot doesn't slip. So maybe we'll start a new English word and call it gription.
Yeah, I think we should. We should patent it now. I think that's great.
Now, this is a case of how do you move a $250,000 Bentley? That's literally how they unloaded it off the carrier. This was at one of my customer sites. I had to take a picture of it. So this is an application that has nothing to do with thermal spray other than it was across the street from where these guys were doing it. It's bizarre. Yeah. This is a company that deals with salvage autos. And this came out of some kind of salvage thing, whether it was in a flood or was stolen, I don't know. But they buy these off insurance companies and they literally offload them using this forklift off the transport.
That's got to be, yeah. I know why you took the picture. I would have done the same thing. This is sad to see. That's scary.
So maybe there's an application where we can spray an anti-skid on the forks of that forklift so the car doesn't slide off. How else do you handle a $250,000 car, huh?
You got to put some gription on those forks so you can hold the car.
Yes. Well, actually, this is a used car, so maybe it wasn't $250. Maybe it's only a $100,000 car.
Oh, yeah. Just $100,000. No big deal.
Yeah. This is actually a really fascinating piece here. This is actually a water screen. So these kind of screens are used at processing facilities that need to draw a lot of water out of rivers, or for that matter, out of the ocean. And they have a problem with barnacles and other sea creatures that will attach to those inlets and eventually plug them up. So this is a copper-bearing alloy. And barnacles don't like copper. It's actually a poison to them. So they won't attach to it. So in this particular case, that shiny spot on top, that's a machine surface, and that was damaged somehow. So they had the machine that undersized. They sprayed it oversized and then remachined it to the right fit. Somehow it got damaged in service. This actually might have been made out of another material, and they could have sprayed a copper-bearing alloy on top of that. They did a little bit of this with boat hulls, but boat hulls are really tough to do because the adhesion you need there sometimes exceeds what kind of adhesion you'll get with a thermal spray process. And it has to do with salt water and, banging the thing up against the side of a dock. There's a lot of factors involved with it. You don't see too much in boat hulls anymore.
I didn't know about the barnacles and the copper reaction. I feel like now knowing that, I feel like it should be used all over the place on boats and stuff like you said, but it probably is difficult to get that material on a boat in a way that makes sense because there are so many other factors. So that's interesting though. I didn't know that was that fact.
There's another interesting side application that's for the same purpose. There is a company out there, and I think I should not say, I won't name them. I don't know if I can or not. But they have an alloy that they can thermal spray that's a copper nickel alloy that's used in hospitals. So handrails and bed rails and things like that, if there's copper on there, that kills viruses and bacteria. So even like with COVID can't live on copper. So there's a company out there that is producing a product that has a high amount of copper in it. And I don't know the exact chemistry that's like top secret. But it's a copper nickel alloy, and it's used for that application for sanitary purposes. Same kind of idea. Copper kills living organisms. So don't eat pennies. That's bad for you.
Yeah, don't eat pennies.
Now, this is a really cool application. Large diesel engines are extremely expensive. So the over-the-road trucks and those big dozers and the big dump trucks you see on construction sites, they have engines that they have 1,600 horsepower. They're very big, very expensive engines. And after they wear out, they rebuild them. In this particular application, this is a rotating thermal spray gun, and they actually machine out the inside of the bores of these cylinders, and then they respray an iron-based alloy in there to bring them back up to size, and they finish machining them. They actually hone them down to finished size, so they can reuse this block. Also on the top, every time they rebuild one of these diesel engines, they have to do some shaving of the top to make sure they clean up any kind of warpage, or they want a clean, straight block. If they take too much off, they have to thermal spray an alloy on there to build it back up, and then they remachine it down to save that block. Same thing with cylinder heads. So this is a big application in the diesel rebuilding. This is an example of a housing. This actually was also off a large earth-moving piece of equipment. There's a bearing that slides in there. What happened there, again, the bearing got damaged, that housing got damaged, so it was machined undersized, thermal spray in that inside diameter, and then remachined out to the original dimensions so this part could go back in service. Again, these large earth-moving pieces of equipment, that's a very expensive part. So in some ways, we have a green technology. We're actually salvaging components. Instead of throwing them away, we're actually salvaging them and reusing them and recycling them to be more friendly to the earth. This is an example of a tube. We did a video on tube mills. So you can take a look around and see we have the whole story behind this. But this is a tube, and this was about a 6-inch diameter tube. And then the very center on the top there, you see like a straight line. That's where there was a friction weld that was accomplished. And when that welding occurred, the zinc that was on the galvanized sheet came off. So we resprayed that with zinc to give it the corrosion protection for when it goes back outside. This one's kind of a fun one. This is actually part of a knee implant. So knees have tremendous stress on them. So they want to make replacement knees out of high strength materials. And this happens to be a 6-4 titanium material that has high strength, but bone doesn't like to attach to it. So you see there's a very rough texture there. That's pure titanium that was sprayed on top of a titanium alloy. Bone will stick to pure titanium. Now, they have various ways of getting bone to attach to implants, but this is one of the technologies that's been around probably 25, 30 years, still used today. I mean, I actually have a couple of the components here. I worked with a company where we built a vacuum chamber to do the spraying. And the reason is that titanium is highly reactive to oxygen. And if you try thermal spraying this in air, the titanium oxidizes. And oxygen in titanium causes high strength, but it causes brittleness. And you don't want your materials on your knee implant cracking. So these parts had to be sprayed in an inert atmosphere. So we started in a vacuum chamber and backfilled with an inert gas so that we wouldn't get oxidation of the material. I actually have that component right here. This is the part that we have the picture of, to show a picture of it. This is the part that goes down in the lower part of your leg. The tibia goes into the tibia, and there are actually some screw holes there. They screw that down in, and then the bone eventually grows on this surface here to give you a high strength. This is the other part to the knee, and you probably can recognize the part here. This is the part that rotates. So this would be in the low part of the body. I should show it like this. This is the way it would be in the knee, and the knee would rotate back and forth like this. Now, metal on metal is not good. There's actually a plastic piece that goes in between, so this glides on a plastic. And this also has a thermal spray on the inside, but you can see here there's a coating in here that's also pure titanium. And that goes up on the upper part, the femur, and it adheres to that. So this goes up into the bone on the top. This goes into the bone on the bottom. And that's how a knee implant's done. I also happen to have part of a hip implant. This is one here. This is the part that goes up into the hip. So it goes up into your hip, and then there's a ball that goes in here that goes down into the lower part of the leg. So that's another example of a medical component that was sprayed with titanium.
Yeah, I'd be curious to see, and maybe there's footage out there somewhere, but just the contrast to the thermal spray process for these types of items, and then they're being put inside people's bodies to help strengthen their knees. I think that's so crazy. Just to see that video from start to finish would be a fascinating contrast.
Well, I have that video, but it's not for prime time. It's not. It's actually, if you watch it, you may not ever get a knee implant done.
Oh, no. Oh, man. All right.
It's pretty brutal. I mean, they have hammers and drills, and it's like they're going to a, construction project.
Yeah, that's why I'm thinking in my head, the contrast to what it's actually doing for the body, which is amazing that they're able to do that. But thermal spray's role in that and all the other things that you've shown today, that's fascinating just to see the actual true application of the thermal spray process. So thank you so much for sharing that.
Yeah, if you find that interesting, I probably could dig up some more pictures of other applications. It's always fun to talk about.